Hello everyone, in this class we would try to learn the Radix sort. So before going into the procedure of Radix sort, let's first discuss what does the mean of Radix and how it helps for the sorting purpose. So Radix means a base of any particular number system. Like as we learned from our childhood that the place value, like say a number is given in decimal number system. So if a number is given, then let's say it should be 4. So the place value of this digit would be 1s, then the place value of digit 2 would be 10s, and place value of digit 8 would be 100. Likewise the place value of 7 would be 1000. So that is what something we have learned from our childhood. But if we would like to generalize that concept, like for suppose a binary number system, a number is given, then if I would ask you what would be the place value of this 0 and the place value of this 1 and so on, like octal, in case of octal, suppose some number is written, and I would ask you what would be the place value of this 3, the place value of this 2 and place value of this 6, then the answer would be, in generalized case, the base to the power place. Like here, in case of decimal number system, the base is 10 and the place value of this would be from, this is at 0th place and that first place and then second place and third place and so on. So the place value of this 4 would be 10 to the power 0 and the place value of 2 would be 10 to the power 1 and the place value of 8 would be 10 to the power 2. Likewise 10 to the power 3 and so on. Likewise here, in case of binary number system, the base is 2. Now the place value of this 0 would be the base to the power place. Now the place of this is 0. The place value of this 0 would be 2 to the power 0. The place value of this 1 would be 2 to the power 1. Place value of this 0 would be 2 to the power 2. And place value of this 1 would be 2 to the power 3 and so on. Likewise 8 to the power 0, 8 to the power 1 and 8 to the power 2. So that is how the place value would be calculated in generalized form. Now in Radix sort, what is the use of these Radix? So in case of Radix sort, we sort the number not exactly by their as a whole number. We split the number. Suppose this number is given in, let's say it is in decimal number system, then we are not going to sort it as a 283. We consider this whole number as a composition of 3, 8 and 2, and first we perform sorting on the basis of this unit place number, and once it is sorted, then we perform sorting on the basis of this digit, that is at 10th place, and after performing that on that basis, we again perform the sorting on this 2 on 100th place value, and this process will keep on going till we reach the maximum number which has maximum number of digits. So likewise, if suppose if a number is given, a number series given, a number list is given rather, 382, 60, 593 and so on. So in this case, there is 1 digit number and then 2 digit number and then 3 digit number. It could come in any order. So first of all, we have to make all these number to the maximum number of digit. What does that mean is, in all these number, the maximum value is 593, and this number having 3 digits. So what we have to do as a pre-processing of the data, we have to make all the numbers into 3 digits. So how could we do that? Just pad the number of zeros on the left hand side. So there are 593 is the maximum number, and there are number of digits are 3. So we put all the numbers in 3 digits. So likewise 3, if 3 has only 1 digit, we just put 2 zeros on the left side, so that this number would become into 3 digits. 82 has 2 digit, 8 and 2. So to make it, in order to make it 3 digit number, we just put a 0 on the left hand side. Likewise here we put a 0. So now all the numbers are converted into 3 digits. After this we would perform the Radix sort. So suppose a number is given. In this case all the digits, all the numbers are already in 3 digits. So in order to perform the Radix sort on this list, what we consider the digits at unit place, and we perform the sorting on the basis of that those digits. So like if 9 at the unit place on the first number, the first digit at 0th place is 9, then 779605. So we simply perform a sorting on the basis of these digits only. So we just perform sorting on the basis of these digits only. And if I am talking about these digits, all the number for guarantee would ranges from 0 to 9. No number would have value other than this range if we are talking about the decimal number system. So if range is known and range is fixed, as we have seen our previous lectures, we can apply counting sort here. So and if we apply counting sort, the complexity of this operation would be linear. So after performing this operation, we would get this numbers list. So this number list, the first, let's say if I'm talking, about this number, okay, letter, if I would say this is list 1, original list. Then this would be the list after first pass on the basis of sorting on the unit place number. So now here at first position the 0 would come, then next higher value 5, then next higher value 6, then 7, then 7, then 9 and 9. So on the basis of these digits we have performed the sorting on the numbers. So this is, let's say, list 1. After pass 1, and likewise if we for the next scenario we would consider digits at second place, and if we consider digit and second place, then we perform sorting on this list on the basis of 10th digit number. After performing the sorting on the basis of 10th place number, we just got this list here in this list, and this the third list 2. So list 2 is we can we would get this list after performing the sorting on the list 1 on the basis of tens place digit, not the number. So we perform sorting on the 2 5 3 5 5 2 3, and after performing sorting, this would be the number, like 2 among all those number among all digits at 10th place. This would be a new list, initially 2, because it is the smallest number at 10th place, then next 2, then 3 and 3 and 5 5 5. So that is what we get on the second after performing sorting on 10th place number. And then we simply finally we get this list, list 3 after pass 3. And since there are only 3 digits on all the numbers, and this would be the final list. And now you could see the whole numbers now get sorted. While we are performing sorting on the basis of digits, here we perform on the unit place number, or 10 to the power 0th place value of the digits, then the 10 to the power 1 place value of the digits, and then we performing sorting on the 10 to the power 10 to the power 2 place value of the digit. Now let's see what is the algorithm behind that. What is the final algorithm through which we could perform these operations. Simple algorithm, like A is the number list, or list, I should say simply a list of values which we are going to sort, and D is the number of digits in the maximum number. So like as I told you in this previous slide, that in this case, in this list, if 593 is the maximum value and it has 3 digits, then the value of D would be 3 in this case, and we would convert all the numbers into 3 digits. So D is that number, the number of digit in the largest number. So these would be the arguments, and then a simple algorithm from I to D. So if suppose if the value of D would be 3, then I would take value initially 1, then 2, and then 3, and we simply perform what number is given. So first we perform sorting on this value, I is equal to 1, say is the place value of 1, and T is equal to, in next iteration, I is equal to 2 would represent the place value at 2, the place value of 2, that is tens, and after that the place value of hundreds, and it will keep on going till we reach the number of digits in the maximum number. And what we do in each sorting on a single digit, on the basis of single digit, is any stable sort. It is a simple algorithm. It is written in very generic form, but any stable sort. So what is stable sort? We have discussed in the previous lectures. So if we perform any comparison based sorting, then in that case it would take minimum and log n time. If we go for comparison based sorting. But if we perform the counting sort or any sorting which could be performed in linear time, then it would take on time. So in this algorithm it is written this: any stable sort would perform the desired result, could any stable sort would give you your desired result. But if we perform a linear sort here, which also should be a stable sort, well, in that case it would give you the result with lesser complexity. So as we know, the counting sort is first of all it is linear and it is stable also. So we would go to perform the stable sort, and if we would go to perform the counting sort. And if we perform counting sort, so line number 2 would be performed in linear time. And if it is performed in linear time, and this operation would be go in the order of number of digit times. So what would be the complexity? Order of d into n. So number of digits multiplied by number of numbers. So that would be the complexity of the Radix sort if we perform this stable sort through counting sort. And if we perform this stable sort through some other like merge sort, so well, in that case the complexity would be d to the power n log n. So these would be the complexity of Radix sort if we perform these stable sort through any comparison based sorting, which should be stable. And if it is, we go for counting sort, and obviously for both the cases it should be stable. If whatever sorting we are picking here, if it is not stable, we won't get our result. So this is very necessary, compulsory thing. And whatever sorting we are going to perform, it must be stable sort. So that is all about the Radix sort. In our next topic is the next again non-comparison based sorting, that is bucket sort. So in bucket sort there is some assumptions, like all the data is given in this particular range, that is all the data. Suppose if I am writing this is a number line, so in this case in bucket sort it assumes that all of your data is inside this range only from 0 to 1, and 1 is open, so that means 1 is not included in your list. So all the numbers which could come including 0 and all the value greater than 0 but less than 1, so this bucket sort consider all of your data would reside only in this range. So all the non-negative number and less than 1, and it should be uniformly distributed. What does that means? So if I just zoom this portion, so whatever the data is given for performing sorting on that, all should be equally distributed in this range. So suppose if I have 50 number of data, let's say it is 0.1, this is 0.2, this is 0.3, so on, this is 0.9. So all the data which is given it should be equally distributed. What does that mean? That whatever values are there in these 50 number which is here, that should be almost equal to the number which resides in this range 0.1 to 0.2, and that should be equal to 0.3, almost equal to this. And since all if I divide this range from 0 to 1, if I divide this range into 10 buckets, so all these numbers should be equally distributed to all the buckets. So if in first bucket, if there are 5 numbers, in second bucket it should also be 5, third also 5, and so on. It could be like in some case it is in this bucket 4, in this bucket 6. It is not exactly that all the buckets should have exactly same number, but it should be almost equal, and that is what uniform distribution is. So if our data is in this having this particular property, then we could perform the bucket sort. Of course, a general data could we can perform bucket sort on the general data as well, but well, in that case we have to modify data a bit, or we have to perform a little modification or in our bucket sort algorithm. But in default sense, the bucket sort could be performed only this type of data. So let's see how it works. So this is the algorithm of bucket sort. A is obviously a list of number, and all the numbers are between 0 and 1. 0 is closed and 1 is open. That means 1 is not included in your data and 0 could be included in your data. So all the numbers which is reside in the list A, would each and every number should be between 0 and 1. 0 is included, 1 is excluded. So in this algorithm, simply what we do, we simply perform buckets of some numbers. So how many buckets we are going to create? In case of decimal number system, we would create 10 buckets. So 0, 1, 2, 3 is 9. And what we do, suppose our list is given in array A, there are n number of elements, and we create a array of pointers which initially points to null. So we could perform like this. So initially all the cells are performing all the cells are pointing to null values. Now we pick a number from our list A, and on the basis of the value of this number, we would insert this data into the particular bucket. So suppose if this data is 0.39, then this 0.39 would be here. Now let's say next value is 0.23, then this 0.23 would come here. Next data is, let's say, 0.28, then this 0.28 would first come into this bucket and then we apply here. So likewise, we just put all the data into a particular bucket. So we just read data one by one from the list A, and we put that data into the corresponding linked list of a particular bucket. So if data is starting from 0.2, then it would go to the bucket number 2. If data is 0.78, then this value would come to the 7th bucket, and 0.7 would become. Further, let's say 7 1 would come, then we perform 7 1. So that is how we are going to populate the whole data from list A to list B, and then we are going to perform for each bucket individually a sorting or insertion sort on each of these buckets. And once we perform all the sorting on each bucket individually, then we simply concatenate all the list. Means if I would say this is L1, this is L2, this is L3, this is L4, and so on. So we simply, after performing sorting on L1, we simply would write like this. First we write down all the elements of L1, then all the elements of L2, then all the values of L3. So what does I mean? Simply concatenate all the values. L1 concatenated by L2, concatenated by L3, concatenated by L4, and so on. So once we put all the data in concatenated form, our list will be sorted. So let's see how it is going to perform in this through this algorithm. In line number 1, we simply find out the value of n, how many elements are there. Then we simply perform simply copying data from array A to corresponding position at B. Now what does mean the corresponding position of B? Simply n into AI, the multiplication n into AI, and that is the index number of B. So suppose if I am talking about 23, 0.23, so this is 0.23, and n is the number of elements. So if there are 10 elements, so 10 into 0.23, so that is, and we are taking the floor function of that. So we put this data on in the second bucket. If this is suppose if it is 43, 0.43, then if a value of n would be 10, then 10 into 0.43, it is the 4.3, and we are taking the floor function of 4.3, that is 4. So we are putting 0.43 data at the index 4. 43 would appear here. So that is how we simply put all the data from AI to the array B through some linked list representation. And once we're done with line number 2 and 3, means we copied all the data from A to B, then we perform some sorting on all the indexes. At this point, what we did, we simply put all the data from A to B. One thing you would have to notice, the size of B. The size of B would be depend of size of A. So if there are 1000 element in array A, the size of array B would be 1000. If there are 5000 element, the size of B would be 5000. So what we initially assumes that whatever number is B there in the list A, we would create n buckets in terms of array B, and now pick a element from A and put into the appropriate bucket of into the list B. Now it might happen there are some buckets, after putting all the data from A to B, some buckets are empty and some buckets having some more than one data. Now once we got all the data into the B array through this linked list implementation, we perform all the non-blank buckets. We perform insertion sorting on each and every non-empty bucket. So if there is empty bucket, there is nothing to do, and if it is non-empty bucket, there are more than some data. So we simply perform some insertion sort on all of those data into a single bucket. And after performing sorting on let's say bucket 2, then we go to bucket 3. If there is some data, we perform insertion sort, and after performing insertion sort, we go to next bucket. If there is data, we perform insertion sort. If there is no data, we simply move to the next bucket. and that process will keep on going till we reach the end of the B array, or you could say the last bucket. So that is what is performing in line number 4 and 5. We simply go to from bucket number 0 to bucket number n minus 1. So 0 to n minus 1 means the size of B array is n. So sort list B of I. B of I represents water. B of I represents a particular bucket. So if B of 0 is empty, we are nothing to do here. B of 1 is empty, nothing to do here. B of 2, if there are some data, so we would perform insertion sorting on this data. So that is what written here. Do sort list Bi. List Bi means all the data in a particular bucket with insertion sort. Why insertion sort only? We would take a look on this particular aspect. Why insertion? Why it is specified insertion sort? Why not bucket sort, or why not any other sorting here? So once we perform sorting on all the buckets individually, we simply concatenate all the lists. So all the element of B0 concatenated by all the element of B1 concatenated by all the element of B2, and so on up to the last bucket. And once we perform this thing, we get our sorted list. Now, why insertion sort only? Since we are getting limited data in each bucket, so if we perform insertion sort, that with some mathematics, we could see that insertion sort with some constraint could be performed on linear time. With some mathematics, it is not directly, because we know the insertion sort, the complexity of insertion sort is on in best case and on is square in worst case, but this is not the best case. It is not necessary all the data is sorted here. That is what the best case of insertion sort. If all the data is sorted, then in that case insertion sorting would take on for sure, but data is not sorted here exactly, but it would be almost sorted, and that's why we are approaching to on, some case of linear. But one more thing is here n is the number of elements. Now here, if we are talking about n, now this n is number of elements only in this list and not in here all the data. So the number of data is limited and it is almost sorted. Then the average case of insertion sort in this particular scenario would be linear, and that's why the whole complexity of this algorithm would be linear. Why? Because here the cost of this is constant, cost of this thing is linear, number of elements simply we copy it from one place to another place, and now we perform insertion sort. So here, if there are n buckets and we are performing sorting on each bucket, then in every bucket the complexity is O of, let's say we say n1. Here n1 is the number of element in a bucket in one list. So n into O of n1, again linear. The multiplication of two polynomial is again polynomial. In line number 4 and 5, the n into order of n1, and n1 is the number of element in a particular bucket, and then we simply concatenate, and this would take again bucket times so n. So the final complexity would be linear. So that is how the bucket sort would work. Let's see through an example. Suppose this data is given. So there are 10 data. The size of B would be, again the size of B would be 10, and the indexes would be from 0 to 9. initially all the cells would be null, pointed to null. Since B is a pointer array, so all the pointers would be initially null, and then we read a data from array A, let's say 0.78, and the value of n is here 10. So 10 into 0.78, that is 7.8, and take the floor of 7.8, that is 7. So we put this data onto the 7th bucket, 0.78. Next, 0.17 multiplied by 10, 1.7, taking floor value 1.7. The floor value of 1.7 would be 1, so we put 0.17 here. Then 0.39 would come here, then 0.26 would be here, then 0.72 on 7th bucket, but here already a data is given, so we simply put 0.72 on the next of 0.78. We could also perform this data on the initial header of the linked list, so that we don't have to traverse that thing. We could also tune this way also. 0.94, so we simply at index 9, then 0.21 and bucket 2, 0.12. So likewise we put all the data here. So there is a already data is sorted here. So in this case, why there is a difference between, let's say, this bucket to this bucket? I mean, why there is this difference? Because here I am put, so after inserting all the data from array A to B, we would get this type of list, and then after performing sorting on each and every bucket, we would get this list. But as I earlier said, that if we are going to insert our data, if we put inserting the data like first 0.17 come, then next time 0.12 come, if we insert this data at the tail of the previous data, suppose 0.11 come and or 0.19 come, if we insert this data here, what we have to do to insert here, we simply have to traverse from first data to last data to insert this data. So instead of inserting this data here, we could insert at the initial position. If we do like this, we would save the complexity, time complexity, and ultimately we have to perform the insertion sort on this data. So instead of inserting data at the last position, we would insert data at the first position, though it is not written into our algorithm where to insert. But if we insert at the initial position, we would save the time complexity. So after inserting the whole data and performing the insertion sort on individual bucket, we would get this list. And after attaining this data structure, what we do next is we simply concatenate all the data from all the buckets. So bucket 0, no data, no need to concatenate anything. Then bucket 1 having data 0.12 and then 0.17. So these data are from bucket 1. Then from next bucket 2, 0.21, then 0.23, then 0.26. So all of these data are from bucket 2. Then from bucket 3 there is only one data, 0.39. So bucket 1, bucket 2, bucket 3, and from bucket 4 don't have data, bucket 5 don't have data, bucket 6 0.68 from the bucket 6, and bucket 7 have 2 data, 0.72, 0.78, and then bucket 8 don't have data, then bucket 9 have 0.94. So this is our final answer, the sorted list. Complexity is On, and I'm again repeating, the question may arise if we are performing linear sort, and as we read the complexity of linear any comparison based sorting, the lower bound is n log n, then how could we claim like this the sorting is linear? See, this is the general case, but here once data is distributed equally, one thing. Second thing, this n is number of data, but here there is a fraction of data, not the whole data. So it could be n by 10 or n by 20 or whatever, how many buckets are there. If data is equally distributed, that means we consider that each bucket have equal amount of data. That is assumption, and how much we are close to our assumption we would get this result, and how much we are distracted from our assumption we would get away from this thing. So if everything is ideal, data is equally homogeneously distributed, we get this complexity. If not homogeneously distributed, we would get away from this complexity. So this is expected complexity when under the assumption that all the data is equally distributed. And I'm again once again repeating that all the data is within a range, this thing. So if data is distributed homogeneously distributed within this range, only then this bucket sort is going to perform. So that is all about bucket sort. Thank you.